In the previous video, we were talking about some of the historical predecessors to a relational database, namely the sort of hierarchical model and the network model. And so now we're going to, within that context, sort of say now we've reached the relational data model, and we're going to review some of our sort of standard concepts of a relational data model. So the idea is that of a relation, which is an idea in mathematics, but it often gets sort of realized as a table, which is sort of a two-dimensional array. So we'll say sort of what there are similar things in mathematics, like a matrix or something, and we want to make a distinction of like what specifically makes it a table. So we will do that. But we have this idea of a relation, which is going to end up as being a table. We'll talk about they often represent an entity, though they can possibly represent a relationship. And they are sort of like what used to be in the earliest systems, like files. So that's one of our main components of this uh, relational database model, which was replacing the hierarchical and network models. So we're going to have tables, and they are going to be just a representation of the mathematical concept of a relation. It is replacing the idea of each individual file that one might have found in the original sort of database systems that people built sort of all individually. So we're going to use these terms sort of almost interchangeably: table and relation and file. And so the table is going to be have this sort of logical design. We don't necessarily care what it looks like. It's just that it's the logic of a table is what's important to us. Um, and so we might not be able to peek into the file and see what looks to us like a table, but it's a good enough. It's conceptually a table, and that's what's important to us. One thing that's important is that like table has it. We're going to have more than one table, so we must be able to distinguish one table from another. So a table must have a name. So here's an example of sort of a table of the category table in the Northwind database. And so it has, you can see rows and columns, the sort of constituent components of a table. Okay, so we're bringing together associated data. We're going to at least think of it in rows and columns, and it will often be when it's being represented to us, it'll be represented in rows and columns, sort of like a spreadsheet, like Excel or something. Again, but that might not what it actually looks like behind the scenes. And so when we are getting down to an individual column, then we should specify that it contains data of corresponding to a particular property of the thing we are modeling. It should have a particular type. So, and the example is like the last name of a person, which will be text or string or varchar, or however you want to call that type. And then just like the table had to have a name, the column must have a name so we want to be able to access specifically a specific table with a specific column. So to get at a specific piece of data. And then what makes, now that we have the concept of column, one thing that, there are other things in mathematics, like say a matrix that can be represented in sort of these combinations of columns and rows. But the one thing that makes a relation is that the order of the columns doesn't matter. And that would not be true for a matrix. For a matrix, that is like an important feature of the matrix. It is not an important feature of a relation. You can do first name and then last name, or last name and then first name, so long as they're properly labeled. Who cares what order they're in? And just some vocabulary, we tend to use interchangeably terms like column, field, attribute, property. And here again is our category table, but with a particular column, say the category name. We also have the table was rows and columns. So sort of going horizontally in that picture, we have the concept of a row, also known as a record. And these are sort of particular pieces of data related to a particular instance or object that we are relating. Um, so we'll take a particular person's first name, last name, date of birth, all that information about an individual, a particular individual, and that will make up, that person's record. And so again, interchangeably, we use the concept of row and record and tuple. And another sort of, we said the difference between a relation, say in a matrix, was we didn't care about the order of the columns. We also don't care about the order of the rows. It will be important that we can distinguish one row from another and be able to identify it, but but the explicit order will not be important to us. And so there in our picture is a row. Sort of this is a particular category. It's got the ID of one. It's got the category name of beverages. It's got a description, some kind of timestamp. It appears to be there. So the the columns define the data type, and there's more about the schema, the types of properties, whereas the row is a more of a thing of the instance, a particular piece of data. And so just visually, again, we have all these different terms, but the column or the attribute or the property, the field, uh, we imagine sort of going vertically, horizontally. We talk about the record and the row and the tuple. And then the overall, the collection of both rows and columns, we call the relation or the table, and sometimes the file. Okay. We have our column, our field, and it comes to make sure that the data going in makes sense. We often define not just a type, but we can define a domain, sort of a set of values. So it could be a particular set of values, like if you have the address broken down and you have, say, a state in the US, then you might say, here's my list of states. So that can only come from this set of things. So it can be a particular set of things, or or it can be, say, numbers that must fall in a particular range, or we can say that it's a number that must be positive. Um, we can specify things like if we're making up IDs, not doing some auto increment, but we're making up our own IDs, or we have some like product code, then we might say it's 2 letters followed by 4 numbers, or so we have we can have like explicit set of values that can be pulled from, or rules it must obey, but these are all go into defining the domain. And so then making sure that your values are in the domain is the domain constraint. So just more vocabulary. So here we are in a picture of Microsoft Access, and you can see that they have different ways to uh, define domains or have validation rules to make sure that what somebody is entering sort of like fits the domain, or obeys the rules set down by the database. So you can have an input mask. So there may be, say, an input mask for a telephone number where you can um, say that it's going to be numbers of a certain length, and it could be, or you could have a validation rule. You could say it's got to be greater than 0, or it's got to be, less than 10. So um, the validation text is just sort of saying um, more things about sort of like what problem. So if the person were to type something, you might say, tell them what the rule is. Otherwise, it's terribly frustrating. So that's the idea of a domain. What else? While we're talking about tables, we have the concept of a one way to characterize a table is its degree. That's sort of uh, how many fields, how big are the what size tuples, how many fields are there, how many columns are there. Um, the number of records. So you could say you could talk about it as being the number of fields. You could say about it being um, how many components does a tuple have. Then the number of tuples or the number of records, that's known as the cardinality. So the degree, number of columns, uh, degree, number of columns, cardinality, number of rows, and then again, our separation of sort of uh, logic design versus actual data instance. And so that degree property is a property of the design of the schema, whereas the cardinality is a property of the instance. How much data have we put in? Okay. So if I'm going sort of across and seeing how many of the columns there are, I am looking at the degree. If I'm counting up how many rows there are, I am talking about the cardinality. We talked about that we didn't care about the order of the rows. That's our idea of relations is we don't care about the order of the rows, but we care that they are distinguishable and that they are distinct and distinguishable, that we can locate one. And we often do this by having a key. And so we can have a field or a set of fields within the table that is unique with for each record. And then if a field or set of fields has this property, then it can serve the purpose of identifying the row. Then it's known as a candidate key. And then we will pick a particular field to serve the purpose, and then that will be the primary key. And so we mentioned previously that in the development of databases, one thing that Cod was very worried about as he was developing the concepts of relational database was redundancy, sort of storing the same data and either wasting space by having it stored multiple times or having this idea of the update anomaly of updating it in one place and that update not reaching the other places. And he developed this concept of normalization. And these candidate keys and primary keys play a role in that process of normalization that we will discuss another time. Um, we have to make sure a key is unique. So we may be looking at some instances, and we have to know that it will be unique for all the instances to come, and not just for the exact. We might have some example data, and we want to make sure that it's really something that will genuinely be unique, and not just something that happens to be unique for the situation that of what our limited view. So we've got to imagine what might come in the future. Um, we don't want it to be fields that might change. So, you might say somebody's first name and last name are you expect them to be unique, or maybe throw in the birthday or something like that. But then somebody might change their name, and so then you probably don't want a key that that could change. Um, got to worry about the key may be needed to actuate certain things in the database. And so if the piece of information has other uses, like a social security number, then you might not want it floating around, even if it is uniquely identifying the people, especially if your system is limited to the US, then um, it may serve the purpose, but be a bad choice nevertheless. Um, and so that can be why you just might have the database make its own uh, primary key, and most database management systems have that sort of feature built in. Um, One of the purposes that we said of the key is to uniquely identify the row within a table. Um, and it's also used typically for sorting the data, finding the data, sorting the data, but it's also used to establish relationships. So it will, when data in two different tables are related, that's often done by having the in one table have a foreign key that is equal to the primary key of another table, and that establishes a relationship between those two records. That those two records have a relationship and sort of belong together in some way. And that's it for this one. Just a quick review, mostly of our ideas of a database, but within our historical context of hierarchical models, followed by network models, followed by relational models. Thanks for your attention.